Okay. Hello. So today we'll be learning how we can connect a front end, that is React, with the smart contract. Um, and we'll be using. Okay. So first of all, the flow of the um, today's seminar would be: first we'll go through the tech stack and the libraries that we've used, and then we'll have a quick walkthrough of the code. Then we'll have a working demo. We'll see the code in action, and then we'll answer some of the questions, and actually all of the questions. And then I do have an assignment for you at the end, which could like a week's assignment. So let's get started. So for the tech stack, I've used Truffle. Truffle basically is a development environment where I can write, test, and deploy my smart contract. And we'll see how we do it in the code later in the later part. And Infura basically gives me a node using which like I connect to the Infura node, and that node is a full node on the Ethereum network. And there are many like networks on the Infura, the mainnet, the Rinkeby the Ropsten network, etc. So you can connect to any of those. For this project, I picked up the Rinkeby test network. Then I use Metamask for authentication and signing in the transactions. Then Web3.js, it's a library that lets me lets me communicate with my smart contract. And we'll also see how it does that. And React to make my life easier, to not use vanilla.js, and Bootstrap to beautify the website, and .env to basically store my mnemonic keys safely. So any questions here?
No, we are good.
All
Okay.
good, all good.
Okay. So give me a minute. We go to the code, but before going to the code, we go for the structure, the folder structure that we have. By the way, you can get the code from the GitHub. We'll share the link. Okay.
Avi, just a moment. So let's say you have installed everything in your system and then you pushed it to GitHub, fine. So if someone pulls it, so I think it won't run directly, right? They have to install again.
Yeah, you have to run npm i. So that installs all the packages that I've used.
So is there a dependency file?
Yes, there's a package.json file that I have.
All right.
Lists all the versions, like all the packages or the libraries with their version that I've used.
Superb. Yep.
Yeah. So the contracts folder is where we write the contracts. For this project, I've written a very simple contract wherein we store the favorite number, and like there is an event that gets emitted whenever a user stores their number. Okay, and migrations is where it's simple. Like the migration file is used to deploy your smart contract to the blockchain network. We'll see how we use this file. And in source folder is where my front end lies. The React part lies inside the source folder. So I've got my components, I've got my context, I've got the contract ABI. This is the most important part. We'll see this. And then I've got my tests. So you can write tests in Truffle using Mocha. I've not written tests for this project because this was a very simple one, but you could write tests over here. And then we have the Truffle config file. So basically, out of the box, Truffle will not give you the HD wallet provider. This is something that you need to install, which should get installed when you install the packages from the package.json HD wallet provider. So what this provider does is that it allows us to connect to the Rinkeby network over here using this HD wallet provider, which is provided to us by the Truffle community itself. And yeah, so to connect a code to the network, we need this wallet provider, and this wallet needs two things. It needs the address where the address of the node. So this is something that I got from Infura, and it needs your secret, your 12-word key phrase, which you can get from your MetaMask. So these are the two things that are required, and then you will be able to connect with your Rinkeby network. And one more thing that I've changed from the default truffle config.js file is that I've added this one line, which lets me the compiled um, the compiled contract, which is the simple storage contract, the ABI, and the other things are generated inside the contract ABI folder. By default, it would be outside the source folder, and which gives an error while trying to import it in your React project. So that is why I've changed the path over here for the contract build directory, and everything else is by default. So any questions over here? Any part?
I have one question. So when you created this template, am I audible?
Yes, yes, you're audible.
So when you created this template, you had what one truffle in it and one npx create React app. So how did you merge both of them? It was like I still don't know. I create two different folders for that.
Okay, so what I did is I did a truffle init. It gave me all the folders, but the source folder, or what you could do is npx create your app and then truffle init. So truffle init would give you the config file and the contracts folder and the migrations folder. Correct?
Yeah.
Yeah. So all we need for the React to communicate to the smart contract is the ABI. Other things are not important for it. So basically now with this one line, I've changed the default path of the build files from say somewhere in the root to inside the source folder. So now my React app just needs this file. I can remove all of these and the app would still run.
Yeah, but when I try to do that, I create actually two different folders, but I want one package.json to have all the dependencies. So what I'm
So
trying to say
what?
is,
Yeah. So what I did is I first created my React app and then I did a truffle in it.
okay, in that only. Okay.
Yes, yes.
So you have to do it in the same folder. First create an app, and
Yes,
then in
create
the
an app
same
and then
folder install the
yes,
truffle.
All
yes,
right.
exactly.
Thank
No
you.
need to change directories over there. Okay, so now that we know how we are connecting our front end, or sorry, the truffle with the Rinkeby test network, let's see how we are actually communicating, how we are reading the smart contract in the React app. So for that, um, when you do a truffle migrate, this will create this file, simple storage.json file, and inside that we have one ABI. This ABI actually contains all the information about the smart contract, like the function name should be there. Like we had an event number saved in our contract. If we go and have a look, so we have an event number saved, and we had a function by store number. So there should be a function uh, store number. Yeah, so we have a function with the name of store number. So basically, the ABI is kind of a metadata of the entire smart contract that we have. So to connect, so basically to communicate with this, for a React to communicate with the smart contract, we need the ABI and the address where the smart contract is actually deployed. So address is also present in this JSON file itself. Address is under the networks section, and then your yeah. So the address where this contract is deployed is under the networks field of this object. So these are the two things that we need to communicate to our smart contract, which is deployed to a deployed smart contract. Okay. So to make my life easier, I've created two contexts. One is the account context, and the other is the smart contract. Basically, the simple storage is contract. So, do you guys know about context in React?
Yeah, I searched, that hook, and I studied that, and I created my own template from inspired from this only by
That's
contest
perfect.
use contest, and it made my life so much easier.
Yeah. So now you don't have to write same code everywhere. So you can like pass
Exactly.
on your accounts to different components just from one file. So that is why I actually created these contexts. So basically, the account context is where I log in or register my user, and I do this using the API of Metamask. So first step is for me to like let the user connect to the Metamask. I'll actually start the app also. So the first thing for me to access this is to connect to the MetaMask. So when I click this button, because of this request accounts method, we get a pop-up over here. And then my account is connected over here. Okay, and there is a listener that is given by, okay, we'll go to the listener in the later stages. So basically, what I'm checking over here inside this connect to MetaMask function is, if MetaMask is installed, then use the window.ethereum. Basically, window.ethereum is injected into our browser by MetaMask, using which it communicates with the um, blockchain. So basically, using the each request accounts method, I can fetch the accounts, and accounts of zero is the first account that is present over there, and my current account becomes the zeroth account, the one using which I logged in. I need to switch the network as well. Okay, and one is the account change handler function. So what happens is, if I change my network, like currently it is C1 E1, if I change my network or switch my network from here, then automatically it gets updated. It gets updated because of this account change handler function. So again, this is a listener. This is a method given by MetaMask itself, wherein you can listen to whenever there's a change in account. So you can like fetch the accounts. So if we go uh, to navbar, there should be a listener somewhere. Uh,
Window.ethereum.on. That's what you're saying.
yeah, that is what I'm looking for. There should be a listener. I'm not able to find it right now. But yeah, there's a listener which actually listens and calls this function. So and then it fetches the whatever the current account is there in your MetaMask. Okay. So this is all about the context accounts context API. And in the contract API, what I've done is I've this is where our Web3 library comes into action. So first of all, I've imported the simple storage JSON file in an object, and then I've taken the ABI and the address where the contract is deployed, and then created an object of web of a contract over here using the Web3 library. So now this contract temp is the variable which I'll be using. Um, Basically, this gets set to contract, and this is the variable using which I can access any variable or function or event that we had in our contract. And this is what I've passed to the like the various components that require this contract. So first of all, we get the web3.given provider gets us a provider, and it's only using this provider that the Web3 the Web3 object communicates to the yeah, provider of the node, and hence it then gets connected to the blockchain. Is that part clear?
Yeah, yeah.
Okay. So next is we've done this. So we can now go for the main code. Yeah. So this is where I was talking about this listener. It's available at the root of my React app. So anywhere on this app, whenever there's an account change, this is a listener that is given to us by Metamask. I call the account change handler function, which we saw over here. So it fetches the current account. So then we go to home component, which has a simple storage thing. So first of all, whenever the page loads, I get the favorite number from my contract. And how do I do that? This is the object that we created in the context, the contract. It basically is like a variable that is pointing to our contract, gives us access to all the variables and the methods. So now to call a method in Web3, we cannot simply just write like this. This won't work. We actually have to write a call as well. So what call means is it's a function using which you're just reading the data from the blockchain. You're not sending anything. You're not making any transaction. So either it's a dot call, function call, or it's a dot send call. Okay. Like when we send a number, that is when we are trying to do a transaction on the blockchain. It is then that we call a function, we pass on the variables, and then we call a send method on it. That store number should send, that is, it is making a transaction and from the account. And this account again is whatever the current account is there on Metamask. So, and these are simple checks on the form. So this is a form, basically we'll just see it over here itself. So currently the number stored is 69 over here. We can change the number. Should take some time. It will ask me to sign this transaction. And the number is updated. And it gets updated over here as well. So you can go through the code for the React part. I skimmed through it because it was less, like the important part was just this one, wherein like how do we call the functions of a contract. This was the important part which I've discussed. If you have any doubt over here, I can explain in detail. but rest of everything is simple React itself.
So connecting is an async function, right?
This one, connect to Metamask. Yes, because it takes some time, so everything is an async function. It returns a promise, this one, so I had to make it async. But if you want promises, you could do that dot then and dot catch and as well.
Okay.
Any more questions? Anything? Any part that is not clear, I can go through it again.
None from my side.
Yeah, all clear from my side too.
Okay, then I do have an assignment for you guys, which I think you can take a week's time or more. So basically, like in your previous assignment, you created your ERC 721 tokens, right?
Yeah, we created ERC 721 and a staking contract.
Yeah. So what I want is that you create a simple game using, say, a number guessing game. Create a smart contract for it. Deploy it on the. You can deploy it anywhere. You can deploy it on localhost as well. Doesn't matter. But I mean, just deploy it and share it on GitHub. If it's deployed on LiveNet, it's fantastic. If not, then it's fine. We'll install it on our local host and then use it. And what we want is that, say, in the simple number guesser game, if someone creates that, then it should be like, if I win that game, I should get some of your ERC 721 tokens as reward. Is that clear?
Yeah, but do we have to use Chainlink's VRF, or we can use a simple Oracle that we can create ourselves, or it has to be Chainlink VRF only for creating the. Okay.
I don't think there would be a need for this oracles and all. It should be a very simple contract wherein when you when a person guesses a number and he guesses it correct, then it should trigger the transfer function of your ERC 721 token. And to get inputs and to decide like what is the random number, for that you need to have a separate contract for the game. It could be any game. You could have like, can you click 10 times on the screen in 10 seconds or in 5 seconds? If someone does that, it should trigger the transfer function. If not, then there should be some message printed out. This was your record or something like that. And you can use events to log out the information, and using those logs, you can maintain a leaderboard on your homepage or wherever you want.
Okay.
Any questions on this one?
And one more thing, just for all, I think Rinkby and Ropsten are getting decommissioned soon. So I think we all should switch to Gorilla as soon as possible.
But currently, I think Gorilla also uses proof of work method only, so it doesn't matter.
Yes, but they are going to maintain it, but Rinkby and Ropsten are not going to be maintained further.
On that sign, you can choose any network. You can even make it on polygons. Doesn't matter.
Yeah, it's all up to you. Just for the information that it is going on.